This question is from GATE 2015 Mechanical Engineering paper set 2. Question number 38. A hollow shaft DO is equal to 2 times DI, where DO and DI are the outer and inner diameters respectively, needs to transmit 20 kilowatt power at 3000 rpm, revolutions per minute. If the maximum permissible shear stress is 30 megapascal, D naught is. Let's write the given information. A relation between outer and inner diameter is given. D outer is equal to 2 times D inner. Power that is to be transmitted is given as 20 kilowatt. Let's convert this to SI unit. So it will be 20 into 10 to the power 3 watt. Speed of the shaft is given in terms of revolutions per minute, which is 3000 rpm. We have to find out the DO, that is outer diameter, if maximum allowable shear stress, tau max, is 30 megapascal. Let's find out the outer diameter. First thing, so we'll start with the relation of power and torque. Power is equal to torque applied on the shaft into its angular velocity omega. We can write omega in terms of speed in rpm as T into 2 pi n by 60. We have power given, so we can substitute this as 20 into 10 to the power 3 is equal to. Torque is not given to us, so T is unknown, into 2 by 60 gives 1 by 30, so we can write pi into n is 3000 and this is 30. So what we get is T is equal to 3000 by 30 is 100 pi. So here 100 pi comes in denominator. We have 20 into 10 to the power 3 divided by 100 pi. Torque that we get from here is 63.66 Newton meter. Let's find out the outer diameter now. So we'll use the pure torsion relation or the pure torsion equation, which gives T by J, polar moment of inertia J, is equal to shear stress at any radius r divided by the radius r. Now to find out the polar moment of inertia, because polar moment of inertia is in terms of inner and outer diameter, so we can first find out polar moment of inertia. Let's rearrange. J is equal to T into R by tau. Let's substitute tau as the maximum shear stress. So we'll substitute tau to be the maximum allowable shear stress. And of course, if it's the maximum shear stress, R will be equal to its maximum radius, outermost fiber of the shaft, which is nothing but which is at the outer radius. So R will be equal to D naught by 2. After substituting these values, we will get 63.66 into D outer by 2 into tau max is given to be 30 megapascal. So it is 30 Newton per mm square. Either we can convert T into Newton millimeters, or we can convert the tau max into pascals. So we'll convert T into Newton millimeters, which is into 10 to the power 3, because this meter has to be converted to millimeters. Now we'll get the J value in mm raised to 4, which is nothing but in terms of DO or outer diameter, this is 1061 times T naught. Now we know what is polar mass moment of inertia for a circular cross section with hollow section. It is nothing but J is equal to pi by 32 into D outer raised to 4 minus D inner raised to 4. This is being calculated here as 1061 D naught. We also have a relation between D naught and DI, which is D outer DO is equal to 2 times D inner. After substituting this over here in place of D naught on both the sides, we'll get pi by 32 into D naught is 2 times Di. So it will be 2 raised to 4 Di raised to 4 minus Di raised to 4 is equal to 1061 into 2. So this gives us 2122 times Di. We'll get the inner diameter from here, which will be Di raised to 4 by Di is equal to 2122 into 32 by pi into, we have 2 to the power 4 minus 1. 2 to the power 4 minus 1, which is nothing but 50. After solving this in the digital calculator, we have di cube is equal to 1440.97. So we can calculate from here. Di is cube root of this value, which is 1440.97. This comes out to be 11.295 millimeters. Now, because we have used torque in terms of Newton millimeters, and shear stress tau in terms of Newton per millimeter square, we have directly got the value of diameter in millimeters. So no need to convert this value into meters or anything. We have directly got in terms of millimeters, which is required. But we were asked to calculate the outer diameter. So we'll take d naught is 2 times di. If we substitute this value here, we get 2 times 11.295, which is calculated as 22.59 millimeters. Let's fill in the answer. So in the options, we have 22.58 millimeters. Option B is the correct option. If the maximum permissible shear stress is 30 megapascal, outer diameter is 22.58 millimeters. To learn more about torsion on shafts, you can refer to the NPTEL video Lecture 18 Torsion 1 from the course Lecture Series on Strength of Materials by Professor S.K. Bhattacharya. He is from Department of Civil Engineering, IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.